You're welcome to online lectures with From Eternity the Schoolboy. Today we'll take a look at physics and we have a question on the board. The question says the velocity v of a wave in a stretched string depends on the tension T in the string and the mass per unit length mu of the spring. Obtain an expression for V in terms of T and mu using the method of dimension. The question source is 2020 WASSCE Physics Theory Question 4. Okay, this question is under dimension of physical quantities. So they want us to determine the expression joining this, and this. So express this in terms of this and this using dimension. Alright, remember that in dimension of physical quantities, these quantities will be broken down to their, if it is a fundamental quantity, fine, wonderful. Just move from the quantity from the SI unit down to its dimension. Something like mass, from kilogram you transform it to m, which is capital M. Another one is distance, which is in meter, or length, which is in meter, bring it down to what? Capital L. Another one is time, which is in seconds, bring it down to capital T. So, but if it is a derived quantity, from the formula, it come down to the units, then come down to this. At the end of the whole thing, you break it down to either of these two, one of these, two of these, or even three of them. So that's what we want to do. So we want to now, you break down this. This is velocity, this is tension, this is mass per unit length. We break it down to these units, this MLT. With this now, we can now really know their powers. From their powers, we now equate their powers to the powers of dimensions of the velocity to be able to determine these powers. When we do that, we now take the power back to substitute it in this expression and have a clear picture of what the expression will look like. Now let me put all these long stories in mathematical form. Now, from what they state here, that we should express V in terms of expression is not an equation, so it will have a sign of proportionality. So we have V, T, and mu. So we have V will now be expressed in terms of tension and what? Mass per unit length. We don't know whether it is inverse proportion, direct proportion, or direct variation or inverse variation. We don't know. We just raise this to either power x and raise this to power y. We leave it at this. Our target is to find this x and y. And having gotten the value of x and y, we cannot put it back into this expression to see exactly the picture of what this thing will look like. Now, but for us to be able to do that, we must break this thing down. I think I need more space. Let me create more space here. Will it be too tiny? I don't know. Let's continue. We break this down to their various dimensions. Now, basically, for us to remove sign of proportionality, we may remove it, we may not remove it, we may just leave it like this and continue our calculation. But it's better, let's remove it. if you remove this sign of proportionality, we introduce a constant. So V is now equal to what? K T raised to power X mu raised to power Y. T raised to power S mu raised to power Y. K is constant, is dimension. This K, we don't bother about the dimension of this because it has nothing here. So we not bother of this. Our focus is on this. Now, so what are we going to do now? Let us work. Let's break this thing down. These things is in just the symbol of the physical quantity, the symbol of the physical quantity, the symbol. This thing is mass per unit length. So we still break this one down further. We have that velocity is now equal to what? K times raised power X, then mass per m raised power Y, m over length, mass over length raised power what? Y. Remember that this T is tension, so it's a force. So it has the SI unit of force, which is Newton. But Newton need to be broken down further. What is Newton actually? What is force? So we can replace this with force. So we have V is equal to, because we want to deal with the symbol of the unit, physical quantity first, before we go down to the units. We break it down properly. Is K. K is K first is power X. Then mass, it becomes L raised power minus 1. So this becomes ML raised power minus 1, or in bracket we have what? Y. Okay, what else are we going to do? Let's break this. This force is this force now. We need to break it down to get the actual what? Quantity that make up this force. Remember that force is equal to what? Mass times what? Acceleration. So velocity now is now equal to what? K. Whenever we see force, we replace with the mass times what? Acceleration. So we have mass times acceleration, or bracket what? Raised power what? X. Bracket open again, mass times length, or bracket raised power what? Y. Let me clean this so that it will be clear. Raised power what? Y is here. So what are we going to do next? Okay, if you look at this thing now, this is the unit, this is the symbol of physical quantity, which is velocity. This is symbol of physical quantity, which is mass. Symbol of physical quantity, which is acceleration. Symbol of the physical quantity, which is mass. Symbol of physical quantity, which is what? Length. So we have succeeded in getting the symbols that make up this. So then let's go down to their unit, SI unit. SI unit of this one is velocity is meter per second. Meter per second. So meter per second is equal to K. This mass, this M is mass, so it's kilogram. This acceleration is meter per second square, so it's meter per I don't think this space will be enough for us, so seems I made a mistake by. Okay, let me see how it will cause issues. Let me clean up, please. I didn't calculate well. Let me clean up. Let me bring this thing here like this. Sorry. Let me so we have enough space. So velocity, the SI unit of velocity is meter per second. Is equal to K, bracket open. That of mass is kilogram. That of acceleration is what? Meter per second squared. So meter per second squared, or bracket raised power what? X. That of mass here is what? Kilogram. Length is what? Meter. So per meter, or raised power Y. We have succeeded in getting them to their what? SI units. So we now move these SI units to the dimensions. In dimension, remember I said that meter is length, L, capital L. So here is what? L. This is second. Second is time, capital T. T is power minus 1 is equal to what? K. bracket open. This is kilogram, mass for mass, capital M in dimension. This is meter, which is capital L. This is seconds, which is capital T. T raised to power minus 2, or raised to power X. This is kilogram, mass, capital M. This is meters, capital L. Raised to power minus 1, or raised to power Y. Good. This is where we are now. Have you seen? We have reduced all these things to what? MLT. Now, so let us now use law of indices to do this thing now. So here we have LT raised to power minus 1 is equal to what? This is K. So if you open up everything now, we have this power multiply the power of everything here. So we have M raised to power X, L raised to power X, T minus 2, this is 1, 1, hope you know. Minus 2x times x is minus 2x. Let's open up this one. This is already M raised to power 1. So 1 times y becomes what? M raised to power what? Y. This is minus 1. Minus 1 times y, L raised to power minus y. Permit me to clean up so we can continue. I will leave this in here because it will help us to substitute the values of x and y. Okay, so let us continue. I will leave the last one so we see where we stopped. Okay, so this is where we stopped. So what do we now do? We look for the one that we collect like terms. So L T raised to power 1 minus 1 is equal to K will still be there. This is M. Is there another M here? So this M raised to power X. Remember the law of indices. M raised to power S, M times M raised to power Y. Don't worry, we'll come there. We collect like terms together. We have L raised to power X times L raised to power minus Y. So we are done with this. 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 What is remaining is T raised to power minus 2x. Okay, let's continue. LT raised to power minus 1 is equal to K is still there, the constant. Remember the law of indices. If you have A raised to power X raised to power A times X raised to power B becomes what? X raised to power A plus B. Remember law of indices. So let's apply it here. M raised to power X times M raised to power Y becomes M raised to power X plus Y. L raised to power X times L raised to power minus Y, it becomes L raised to power X minus Y. This one is still there, T raised to power minus 2x. We have arrived somewhere now. So there is M here, but there's no M here. Remember, M, any number raised to power 0 is 1. And 1 times this thing will give you the same thing. So we can confidently introduce M raised to power 0 here. So we have M raised to power 0 LT raised to power minus 1. Remember, here is 1. M raised to power 0 is 1. So if you so it's something. So we now I want to equate. We want to be able to just put M here. So everything here will complete there. So we have K raised to power K times M raised to power X plus Y, L raised to power X minus Y, T raised to power minus 2x. So from law of indices, M raised to power 0 is here, M raised to power X plus Y is here. We can equate two of them, cancel the base and get down the what? Powers. So let's do that. So what it means is that M raised to power 0 is equal to what? M raised to power X plus Y. Let me write it well for want of space. M raised to power 0 is equal to M raised to power X plus Y. M will cancel M. This implies that 0 is equal to X plus Y. Equation 1. So let's solve for, let me clean this now. Let's solve for L. So L here is equal to L. Remember, this is L raised to power 1. Remember, L raised to power x minus y. L will cancel L. This implies that this one here is equal to x minus y, equation 2. So let's solve for t. Remember, t raised to power minus 1 is equal to t raised to power 2 minus 2x. T will cancel t. We are left. This implies that minus 1 is equal to minus 2x. This is equation 3. So from equation 3, we can solve for x. Very, very easy. Let's from equation 3. Minus 1 is equal to minus 2x. We divide both sides by minus 2x. Minus 2, sorry. So we have here minus 2, minus 2. Minus we cancel minus. This we cancel this. This implies that x is equal to what? Half. X is now what? Half here. So x is equal to what? Half. We have gotten the value of x. Simple. So let's solve for y. If x is half, from equation 1, any of them can help out. We can get the value of y from any of them. But let's solve from equation 1. From equation 1, remember that x plus y is equal to what? 0. See it here. But x is already what? Half. So we substitute half for x. So that means half plus y is equal to 0. If half plus y is equal to 0, if you make y the subject of the formula, y will now become what? 0 minus half, which is what? Minus half. So x, so let me clean up from here. From what I just did now, x is equal to half, y is equal to minus half. If you test it from equation 2 to give it center, remember from the equation 2 I just cleaned now, that's x minus y is equal to, I think, 1 or so. See it now. So x is half minus half is equal to what? This turns to plus. Half plus half is 1. So it's correct. So x, let me now clean well. So x is now equal to, we've come to the end of this question now. X is now equal to half, y is equal to minus half. So we substitute. Remember we negated k. We substitute. Why we put k is that so that we can put sign of equality and be able to solve the question. So we now substitute the value of half for x here in this expression and minus half for y in this expression. Let's do it. So v is now proportional to what? Tension raised to the power of what? Half. And mass per unit length raised to the power minus half. So v is proportional to what? Tension raised to the power half. Remember the law of indices. Mu raised to the power minus half. That minus for this minus to disappear, mu will come down to the denominator. So we have things like something like this. Mu raised to the power what? Half. The negative sign, this is the inverse. The inverse what? In indices, we call it the inverse law. So this thing will now come down. The negative sign will disappear. So we have mu raised to the power half. Remember that if you have this tension raised to the power half, mu raised to the power over mu raised to the power half, there's power half, there's half here as the power, there's half here as the power. So there's common power. So the power will come up for two of them. So we have something like this. V is directly proportional to what? T over what? Mu. All raised to the power what? Half. But remember that any x raised to the power half, law of indices, is equal to what? Square root of what? X, law of what? Indices. So let's apply it here. V is now proportional to square root of what? Tension over what? Mu. This is the expression. They didn't say equation. Question says expression, not an equation. This is the expression that expression between of V in terms of tension and mu. So what does this mean? It means that the velocity is directly proportional to the square root of tension and inversely proportional to the square root of what? The mass per unit length. That is the meaning. So this is the answer to this question. If you want to get an equation, from this sign of proportionality will disappear. If you want to get an equation from here now, the sign of proportionality will do what? Disappear. You now have something like this. Velocity is equal to what? You now have something like this. The velocity is equal to what? K square root of tension over what? Mu. This is an equation. But the question said expression. So that's why I want to leave it like this. So this is the answer to 2020 West Africa Senior Secondary School Certificate Examination, Physics Theory Question 4. Thank you very much for your attention. If you have any question, feel free to drop your question on the comment section. Please subscribe to my YouTube channel. This lecture is streaming live simultaneously on YouTube and on my Facebook profile. My Facebook profile is from our sister Zanya Emmanuel Chetamna, in bracket, from eternity the schoolboy. While my YouTube channel is from eternity the schoolboy TV. The full video will also be posted on my Facebook page, from eternity the schoolboy TV. Please follow and subscribe, comment, like and share these lectures with your friends, your colleagues, your children, your students. Someone out there may be in need of these lectures, and God will bless you abundantly as you do so. See you next time.